Hey students, welcome to the lesson video for 9.5. We are going to continue with this idea of volumes, but instead of cylinders, prisms, we're going to apply it to pyramids, which you studied surface area earlier in this chapter. So let's go ahead and direct you over to my screen here. And in front of you, you should see the key ideas for this section. And once again, we are going to be using a generic formula because a lot of times when it comes to volume, we have so many different shapes, it doesn't really make sense to have all of those individual formulas. So we have a generic formula, and what you're going to find is that it's very straightforward to use, similar to what we did with prisms. It's going to be volume is equal to 1/3 BH, BH, 1/3 base of the area, or area of the base, all right, let me say that correctly, times the height. So once again, we're going to be looking at different types of bases. So the base in a pyramid, as you remember from earlier in this chapter, can be really anything. But then we have a perpendicular altitude / height, and from there, okay, they all meet up at a vertex where they have a bunch of lateral faces. But when we're actually trying to find the volume, we don't really need to worry about those slant heights that you remember from calculating their surface areas. We don't have to worry about that. We just need basically this perpendicular height that goes all the way up through the center of the pyramid. So with that being said, the 1/3 is the only thing that kind of causes some issues with our algebra, but even then it's fairly standard. One variation of this formula you can use is area of the base times the height over 3. It's just rewritten to be a little bit smoother. Some students prefer writing it that way only because you can multiply the area of the base and the height first and then divide by 3 and avoid using that 1/3 crazy looking fraction, because as I know, many of you do not like to work with fractions. All right, so with that being said, let's go ahead and get started with the first example. Let's do something very standard, and you can see how quick this type of work really goes. So what we have here, it looks like a hexagon, but we don't need to really worry about the shape at the bottom. We just know that the area of the base is 48 millimeters squared, and then we have a lovely height of 9 millimeters. So I'm going to go and use BH over 3. And for this example, just because I am going to show you using both equations in tandem, so your choice which you want to use. Personally, it doesn't really matter. I use the 1/3 more often than not, just because I'm comfortable with fractions and I like them. So the area of base is 48 times 9. We're going to divide by 3. Over here, if I use the other version of the equation, it'd be 1/3 times 48 times 9. And after this, you can see there's not too much more than just punching out the numbers and making sure that we're fairly accurate when it comes to putting it into our calculator. I did 48 times 9 in the calculator, then divide by 3. Over here, you could do the 1/3 times 48 first, only because I know that 1/3 and 48 will evenly come out to be 16, a nice lovely whole number, and it becomes 144. Don't forget our units: millimeters squared, millimeters cubed. All right, a little off my game today in this video, but you guys understand the bulk of this is really putting in the correct information. The units are cubed. We're sticking with that because we're dealing with volume, but otherwise, take a peek at this problem and you can see very straightforward if you are given the area of the base. So pause this video as needed, and I am going to go ahead and move on to example 2. All right, let's check this out. So example 2 is when we get into kind of the heart of the lesson. This is where you got to put everything together. So in the first example A, you can see that we're dealing with a pyramid with a rectangular base. So going back to well, pretty much things that you've always known when it comes to rectangular area, it's just base times height, which is 3 times 4, and that's 12. So right away, I have the area of the base equals 12, and that was a simple calculation. 7 is going to be our height, so put it into our formula. I'm going to stick with the 1/3, okay, and there we go. So from here, very standard, punch out the numbers, and everything should be good. So The key things on these is that just recognize what shape your base is and apply the formula accordingly. So I calculated the rectangular base here first, and that would be the general idea for all of these styles. So the next one's a little bit funkier because it looks awkward, but if you're careful, you can visualize that this is the triangle at the very bottom, and it looks like we have a height for the triangle there. 17.5 is going to be the base, and for the base area, it is a triangle, so I'm going to use 1/2 BH, or BH over 2, and put in the appropriate numbers. So we are definitely dealing with some awkward numbers here, so just be careful with your calculations. Let's punch that out real quick. And we get 52.5. All right, 52.5 meters squared. So that's the actual area of the base. And then we can just go ahead and multiply it by that big height of 10. So finishing that off, you can see, once again, very straightforward. And just to switch it up, I am going to use BH over 3. And 52.5 times 10 over 3. It is now a lovely calculator problem. Let me zoom out so you can actually see it. And here we go. Comes out to be not too bad, a solid 175 meters cubed. So these two problems pretty much showcase the bulk of the volumes that I would like you to be working on practicing, or you should be held accountable for in this lesson. That's the main concept. So take a moment to kind of take a peek at that, double check your calculations and your notes, and then I'm going to move on to example 3, where we just take volumes and just move it a little bit further. I'm going to do some application questions. Okay? So pause here if needed. All right, here we go. Now we got a fun one. So this is a great story problem that I want to showcase, because you're going to have to not only find volume, but we're going to utilize it, like actually apply it to a situation and figure out why do we actually need volume. And to be honest, it oftentimes relates to buying things. It all comes back to that dollar. So in this case, we have the volume of sunscreen in bottle B is about how many times the volume in bottle A. So it looks like we're going to have to find the volume of both. And it looks like a typical pyramid, both of them with a rectangular base. And then it asks us which one is the better buy, and I'll have to explain that a little bit. So what I'm going to do is pause the video here, and in about a couple seconds you see all the work show up for A. You should be adding this to your notes as I am going ahead and doing that. And then we'll talk about how to apply that, because the volume itself is very straightforward. All right, on your screen you should see the work just magically pop up, and basically there's just a couple little things I want to explain about the volume setup I did here. Notice that I did what's an inline calculation. Basically, instead of finding the base separately in a different work, I put it into the actual equation, 2 times 1, because we know that we're dealing with a rectangle, and I did the same over here, 3 times 1.5. That's not a shortcut, but it's a nice smooth way to use the formula and put everything into one step versus doing it in separate sections. Anyway, double check your calculations with what I have on mine, and we have bottle A is 4 inches cubed, bottle B is 6 inches cubed. So now we're going to B, where it asks about the better buy. And this is actually going to go a little bit further back to a long time ago, where we talked about unit rates, ratios, proportions, better buys. So in this case, a better buy is going to relate to this price we have here. And a better buy is going to be which one is cheaper by volume. So what we're going to do is just think generically. I'm going to go ahead and take the amount it costs and divide by the volume, because that's going to give us a unit rate per inch cubed, and that will tell us which one is the better buy, because obviously there are 2 different volumes and 2 different prices. We want to see from a unit rate standpoint how much it is per 1 inch cube, so we're comparing the same thing. So with that being said, I'm going to set it up with bottle A. Okay, let me move this off to the side here. Okay, for bottle A, I'll just do the work down here and continue. It's going to be 996 divided by 4, because that's how much the volume is. And then for bottle B, we're looking at 1440 divided by, oops, 6. There it is. Hunting around for it. Can't read my handwriting. All right, so let's check this out. $9.96 divided by 4 comes out to be $2.49 per, right? Actually, I won't put it right that way. I'm just going to write 249 and I'll explain what the units are in this case. And then this other one comes out to be $2.40. That is, okay, you can see that it's a better buy. Bottle B is the better buy because, okay, I'm going to use shorthand B/C because it's less per volume. It's $2.40 per 1 inch cube. Okay, that's the ratio that we calculated here. And by volume, even though it's bigger and more costly, it is still cheaper by 9 cents per 1 inch cube volume. So that is going to be the better buy. So if I was to put an actual answer statement, all right, an appropriate one would be bottle B because its unit rate is cheaper. And that would be appropriate because what we did was calculate the unit rate, and that's often the best way when determining best buy. Okay, so take a moment to look this over. This should give you a clue into some of the homework problems that you will possibly be getting in the online homework. In a moment, I'm going to go ahead and switch you down to the OYO to give you some things to practice. Okay, pause this video here if needed. All right, scrolling. So for the OYO, I've only got 3 questions here for you. Okay, 4 questions, I'm sorry. And what I'm going to do is make it visible, all 4. So take a moment to pause this video. I'm going to let the video roll for about 10 seconds, and then the answers will pop up and I'll go over the explanation as needed. Okay, so check out these 4 problems for your OYO. All right, you should see the 4 answers pop up. Notice I did a lot of inline work. Okay, so I'm going to highlight the base calculations I put in each of these. And instead of separating the work, your choice of how you want to do it. I've shown you a couple versions. And I also flip between using the 1/3 times area of the base times height and also the area of the base times height divided by 3. So you get a look at the different styles. Not much more after the initial inserting of the appropriate measurements because after that it's just standard calculator style work. All right, so with that being said, all right, please review this video as needed. In Big Ideas Math Online, you should see the work for 9.5. Okay? Feel free to reach out to me through office hours or email if you have any questions. All right, thank you.